Hello, everybody. Welcome. We'll get started in just a moment. All right. Thank you for coming over lunch. Looks like we still have a few people joining, so stick with us and we'll get started in just a moment. Just a few reminders. If you have questions, feel free to drop them in the Q&A section at the bottom of your screen. And if you'd like to ask your question in real time, go ahead and raise your hand and I will unmute you. We'll check in periodically to make sure we can answer everyone's questions. All right, I see a few more people trickling in, but I think we'll be able to get started here. All right. Well, first and foremost, thank you everybody for joining today. This is always one of my favorite, programs that Improving offers, a virtual lunch and learn where we can take a bit of time each week, set aside and really take a deep dive into a topic and learn a little bit more. Today, our speaker is the fabulous Michael Perry. Michael Perry's been an improver for 11 years now, and he's a software mathematician. He loves using the power of mathematics to produce provably correct software. He's also the author of The Art of Immutable Architecture. Whew, that's a hard word for me there. And it's a book about mathematically correct data management for distributed systems. So we will be covering a number of those topics in today's talk. So Michael, I'm going to turn it over to you and let you get started.
All right. Thank you so much, Emily. Thanks everyone for joining. And I do want to go ahead and open this up with my usual tagline of, hey, QED coders, this is Michael. But this talk is not just for my QED coders. In fact, this talk is mostly geared toward the business stakeholders because we're going to be talking about application modeling, but we're going to be talking about how you can use these modeling techniques to generate business insights. So there may be some modeling techniques that you've seen used in the past, like entity relationship diagrams, flowcharts, in order to create software models. And these are still very valuable tools for making sure that you build the software correctly and all of the developers understand what you're going to build. But what I'm going to be talking about are software models that don't necessarily tell you how the software is supposed to be built, but instead they drive understanding and insight on how the business actually runs its processes. So these are models that are good for all of our stakeholders to participate in, even if we don't end up writing software for parts of those models. So if you've got any questions as we go along, please go ahead and enter those into the Q&A. I will pause at a couple of points in order to take those questions. And then, of course, we'll save some time for that at the end. So let's kick things off. We're going to be talking about 3 different modeling methods that uncover business insight. The first is domain-driven design. This comes from a book by Eric Evans. Back in 2004, he published this book, and he really talked about how you can tackle the complexity at the heart of software by modeling your domains. So understanding the problem that you're trying to solve. Imagine that. And then we're going to go into event storming. And so this was a technique pioneered by Alberto Brandolini. And it has become a really popular way for all of the stakeholders to come together and document their current understanding of how things work, how the business runs. And so we're going to be diving into how that has helped us and our clients to gain some business insights. And then we'll wrap it up with historical modeling. That's a technique that I came up with back in 2001, and have been gradually evolving it until now. I've got that documented in a book called The Art of Immutable Architecture. What you see pictured here is the cover of the second edition, which you won't find on Amazon quite yet, but it will be there in just a few weeks. So if you are hovering over that buy now button, hold on, wait for the second edition. It's much better, I promise. All right, so let's talk about domain-driven design. So when you read the Blue Book on domain-driven design, you can be forgiven to think that DDD is all about defining your repositories and your entities and your value objects, creating aggregates, defining service boundaries, all of this technical stuff. And it's true, it is about that. But Eric Evans himself has admitted that he wrote the book backwards. The most important stuff is after that. That's really about how you can drive some agreement about what it is that we're actually trying to solve. So focusing on the business stakeholders was really the main driving point of domain-driven design. So I would say that domain-driven design, rather than focusing on the implementation, domain-driven design focuses on language. So let me give you a quick breakdown of the parts of domain-driven design that are really language-focused. It starts with a ubiquitous language. So the idea is that you want to make sure that all the stakeholders are using the same terms when they talk about things. So that definitely includes the technologists who are going to be implementing it. But then also you've got people in different parts of the organization that that need to communicate with one another, and they might use different words to mean the same thing, or they might use the same word to mean different things. Ubiquitous language is about driving that consistency of how we talk with one another. And then we've got a tool that really helps to drive that consistency, and that's the bounded contexts. Now, if you're approaching domain-driven design from a technical standpoint, you might be thinking about microservices, you might be thinking about service boundaries, but really bounded contexts are contextual. They are ways that you can subdivide your problem domain into different areas. And when that comes to a language, a bounded context gives you a single container for your dictionary of these are the terms that I use when I'm in this context. So now your language becomes contextual. And then the third part of domain-driven design is iterative collaboration and refinement. The idea is that you don't do a big design up front, say this is how everything should work, and then you implement your systems. Instead, you iteratively come back to your language, come back to your bounded contexts. You learn from what you've done while you are implementing improvements to the business process, and then you come back and you refine those. So you keep those documents up to date as you do so. So these are the aspects of domain-driven design that I really want to focus on. So I'm going to start with the idea of ubiquitous language. And for this, I would like to share a cautionary tale. So many years ago, when I was first starting in architecture, I wanted to I wanted to make my mark. I wanted to make sure that that I was contributing to the organization. And so one of those ways in which I wanted to contribute was to make sure that that people were using the right language. So we were building a loyalty program, and people would accrue different different units of either they would eat a meal, and so after 5 meals you would get something for free. So you accrue meals, or you might accrue points, or it might just be based on the dollar value. So you might accrue dollars. So that thing that accrues, the business analyst team called that credit. And I said, wait a minute, our domain is adjacent to accounting. People are going to be taking this information out of the loyalty program, and they're going to be integrating it with their general ledger. I want to make sure that we don't reuse that word. And so let's come up with another word. Let's not call it credit. Let's call it something else. And so I said, it's merit. Let's call it merit. Now, that it probably was a good suggestion once, but then when people come back and they say, well, no, we've we talk with our customers and they think of this as credit, and we've got these other stakeholders, and the word credit has already kind of permeated the domain. We can't just go and change the word. At that point, you should probably back off and say, yeah, you know what? Okay, credit it is. We will make do. We will all conform to that ubiquitous language. But no, that's not what I did. What I did was what I said, well, no, there are good reasons that we should use a different word here, and merit just makes a lot more sense, and this is the right way to go. And I convinced people. I convinced about half the team, and then the other half was calling it credit. So we had team merit, we had team credit. Every time somebody joined the team, they would either be introduced by somebody in team merit or introduced by somebody in team credit, and they would become part of that team. And then every time we had a meeting, we had to translate one to the other. Sometimes we would just passively aggressively use our term and just talk over somebody using the other. It was bad. Don't do that. Instead, what we want to do is make sure that that you come up with that ubiquitous language that that everybody can agree upon, even if that means giving up a little bit of what you think is right. So that was a mistake I made a long time ago. I've never forgotten it, and to this day, I keep an eye out for, hey, am I making that mistake again? There are really two problems when it comes to language. There's using two words for the same thing, and then there's having one word for two different things. So I was really worried about that second one. I was really worried about, hey, we're using this word, but it means two different things. And so instead, I forced us into that first problem. Now, bringing this back to domain-driven design, domain-driven design doesn't really have a solution for the first one. It's just like, keep talking until you've got the same word. But it does have a solution for that second problem. In order to solve that second problem, you create bounded contexts. So in the rewards context, credit means that you're giving somebody credit. In the accounting context, credit is the opposite of debit, and it has certain rules in generally accepted accounting principles. So it's okay for that word to have two different meanings as long as those meanings are in different bounded contexts. So now your communication is contextual. You establish at the beginning of a conversation which bounded context are we in, and then you use that ubiquitous language. So that is the technique that events or that domain-driven design gives you in order to solve this language problem. Eric Evans tells us that a domain expert should object to terms or structures that are awkward or inadequate to convey the domain understanding. So this business analyst, as a domain expert, they were right to object to this term. It was awkward. It wasn't what people were using. And developers should watch for ambiguity and inconsistency that will trip up the design. So we've got responsibilities, we've got accountability on both sides of the table here. That we have to make sure that that we aren't introducing language that's awkward, and that we are also making sure that that we look for ambiguity. And that is the challenge and the promise of domain-driven design. So if you've got any questions about domain-driven design or any thoughts or comments, please go ahead and put those into the Q&A. Emily, do we have anything already in the queue?
Nothing yet, but there's still time to ask questions.
All right, excellent. So yeah, make sure that that you get those in. And meanwhile, I will move ahead to event sourcing. And yeah, so if we get some feedback, we will pause and take that. So now, event sourcing. This was a pattern and is a pattern that it's very useful in a distributed system to keep track of a sequence of domain events and perform this left fold over history in order to figure out the current state. It's all very technical, and it really helps to build distributed systems that that have some really valuable properties. But that's all very technical stuff. Alberto Brandolini approached event sourcing in order to try to solve some of these technical problems, and he stumbled onto a really useful technique that helps to create business insight. And so on the back of domain-driven design and event sourcing, Alberto Brandolini created event storming. So now event storming, maybe it started focusing on the domain events and the aggregates and all of that technical stuff. But these days, if you talk to Alberto Brandolini, he'll tell you that no, event storming is focused on process. So how does that work? Let's take a look at an event storming workshop. So you're going to have a set of tools that are available to you. You usually represent these as stickies. So you've got these different things that you can bring into the conversation. The most important one there being that orange sticky, the domain event. Yeah, the second most important one is the one right there on the bottom, the red sticky, where you've got some unknown, some question, something that you want to call out in the conversation. And then the rest of them help to kind of fill out the conversation. But you start with those orange stickies. And then you've got a grammar of how those different things fit together. And for this grammar, time moves across the board. So you're going to identify what is happening in your problem domain, who is doing it, what information do they need in order to make that decision? Are there any policies in place that whenever something happens, they do something? So you've got this grammar of how these cards fit together, and then you collaborate. You just start filling up the board, and you end up with this timeline that represents your entire business process. Now, there's one really important thing that Brandolini discovered about this business process, and it's that some of these groups of stickies are not software. Some of them are just policies that are in place, and people will just execute on those policies, whether their software to support that execution or not. So this is really putting on the board a a shared agreement of what is it that we do, what is it that we want, what we want to do, and then you can use that agreement in order to see how you're going to get there. And how you get there may or may not include software. There's value either way. So let's kind of walk through it real quick. When you are performing an event storming exercise, you're going to ask people to come up with what are some of the things that happened in the domain. So we want to phrase the question as, we jot down that something has occurred. Some decision has been made, some outcome has been reached. So we want this past tense. Now, at first, when you get people into the event storming, they're not going to be thinking past tense, and they might write things down differently. But go ahead and let that flow, and then you're going to now get it down to the place where you are talking about things that happened in the past, like an order was submitted. And then you'll have other people that are putting in different things that happen in the domain. So yeah, okay, this package was shipped, that invoice was paid. And they're going to kind of riff off of one another. So because the order was submitted, I needed to ship a package. Okay, that reminds me. Oh, there's this thing, and then you have in this event storming workshop the stakeholders that are involved in running your business, and some of those stakeholders are technical folks, and some are non-technical. So the technical folks might say, well, you know what, in order to accomplish that, I need to make sure that the user is registered. So part of that process is that the credentials have to be validated. So we've got all of these different domain events. Some of them are the generation of value. Some of them are part of the user journey. Some are things that technically need to take place in order for this to work. So what the group is going to do next is they are going to arrange these in a linear timeline. So time is going to move across the board. And so we say, okay, the user has to be registered before you can validate their credentials, and then at that point they can submit orders. Now we've got this question. Which one happens first? Do we ship the packages first, or does the invoice get paid first? There may be members of the group of stakeholders that don't know the answer to this question. They might not they might not have a good answer to this, and so it's really important to have various members of the organization in the event storming process so that you can answer these questions as they come up. So,
Michael,
yes.
There was a question here about this process.
Oh, very good.
The question was, does an event always represent some decision?
Does an event always represent a decision? I would say that not necessarily. Most of the time it does. Most of the time it represents the outcome of a decision. But sometimes these events are part of the outcome of an automated process. So it wasn't a decision that a person made, but because of some policy, automation took place, and we got a result. Credentials validated might be one of those events in this example. So yeah, I would definitely when I've run these, I've often seen that the non-technical stakeholders will be putting up the ones that are based on decisions. They're just thinking about how people run the process, and that is excellent. That gives everybody a lot of insight. And then it's usually the technical stakeholders that will put those that aren't human driven. Excellent observation. So in this particular example, what we are going to do is we'll say, what? Nope. We actually make sure that the invoice is paid before the package is shipped. So we're going to make sure that that things go in this order. And now that we've got that shared agreement, then we can start to go on to the next phase of event storming. So the next important thing to figure out is who is responsible for each of these domain events. So it's you might say, okay, it's the customer who is responsible for the order being submitted. If a customer didn't submit an order, that wouldn't happen. It's also the customer responsible for for paying the invoice. But it's going to be our logistics department that's responsible for shipping packages. So now you start to bring in not just what happened, but who was responsible for making it happen. You bring in those user annotations. So when a user registers, that was the customer registering. Credentials validated, we're not going to put a user on that one because that one is an automated process. So so we don't need to tie it to any particular person that's responsible for that. So now you are starting to see some collaboration happening. You're starting to see where the process flows from one kind of actor to another kind of actor. And these are really important touch points within a process. So you can see that, okay, after the invoice is paid, then the logistics team needs to somehow know that the invoice was paid so that they can begin shipping the package. So now you can sit down and think about how do they learn about that invoice paid event. It could be that you've got somebody in the accounting department who's picking up the phone and calling the warehouse and saying, "Okay, we just got payment. Go ahead and ship that out." Whatever the process is, document the current process, and then you can start to think about where do we want to evolve from there. But if you start this and some people think that this is just automated, that shipping packages happens by magic, then they might be in for a big surprise when we start to put stickies on the board and we say, no, we went from customer to logistics here, and that's one person picking up the phone and talking to one other person. Oh, maybe we can improve the process. So now that we know who is responsible for what, then we can start to focus in on how do individual events come to be. So let's focus in on invoice paid. We know that invoice paid has to happen after order submitted. So so that part is one of the drivers. But how exactly does the customer get to the point where the invoice is paid? That's the goal. How do we reach that goal? So now we want to think about what is the thing that they are actually acting upon in order to reach that goal. So in this case, we might say that what we do is we track everything at the order level. So the order is the thing that has the invoices in it. The order is the thing that has all the the shipping information, and the order is the thing that has all of the widgets that are going to be picked, packed, and shipped. So the order is kind of the in domain-driven design terms, the aggregate, the thing that that we are starting from. So if that's the way that the organization thinks about paying invoices, that's what goes here. And again, this is all driving that common understanding. And then some of the other things that you might do is what does the customer need in order to make a decision to pay an invoice? Well, they need to actually see an invoice. So this green sticky, this is a view. This is something that that is kind of a projection of that that aggregate. It's some summary of the order, some subset of the order that the customer sees in order to accomplish what they need to accomplish. So go ahead and write that up there. And so now we understand that there has to be enough information in the order in order to produce an invoice. And that's kind of the relationship that we have in our organization. Now, of course, in your organization, it may be different. So please run this this exercise with exactly how you run your business in mind. And then the last sticky that you want to put up there is the command. How does the customer actually accomplish the thing? So so here we've got some pay invoice command that the customer can invoke in order to look at an invoice, pay it, and that invoice came from the order, and that produces the invoice paid event. So far we haven't really talked about the software. We haven't talked about message buses or databases or distributed systems, brokers, any of that. But in order to accomplish this, at some point, customer has to look at an invoice and they have to do something to pay it. And so this is really exposing those parts of the system that you use in order to run your process. And that's what event storming is really giving us. So we're getting close to the end of event storming. If you've got some questions to put in there, then please go ahead and get those in. To kind of wrap it up, here's a quote from Alberto Brandolini. He was recently on a podcast talking about event storming, and he now calls event storming a kind of process modeling. And process modeling is optimized for designing collaborative processes, which may or may not include software. So the whole idea is to design a process. You want that process to be collaborative. If you're not designing a collaborative process, event storming is probably overkill. It's really all about those collaborations. How do the different actors collaborate with one another? What are those points in the process where it goes from one actor to the other? And how do they learn that the ball has been passed to them and they need to do something about it?
And Michael, we have another question in the chat if you're ready.
Excellent. Let's hear it.
All right. What is the role of the command in the modeling process? Is it actually required?
Excellent. Yes. So the role of the command in the modeling process is to really talk about the how. So so here I just have pay invoice, which I'll admit is for this example pretty abstract. How exactly do you pay the invoice? So that might be using an online portal. So what you would really want to do is to document here that the customer is using the online portal in order to pay the invoice. Or this might be that they are, calling up a call center and they are, reading their credit card number over the phone. Whatever that happens to be, that's the command. And that is what initiates this process. So in order for them to accomplish that command, they need to be able to see the invoice. So maybe the invoice arrived to them in the mail. And then they execute the command, pick up the phone, and pay the invoice over the phone. So yeah, without those commands, you just have these things that happen, but you don't know how. So the role of the command is to tell you how. All right. So so event storming has become a really popular technique for driving business intuition and documenting how businesses run processes. And it started from software, but now it's really about understanding, about coming to an agreement. Maybe not an agreement on what we're going to do, but at least an agreement on what we do, an agreement on where we disagree. So so I find it to be an extremely useful tool. And then the third modeling technique, the one that I introduced way back in 2001, is historical modeling. And I originally came up with this idea in order to solve distributed systems problems. So it has things like imposing a partial order among events, having a local replica that you can work off of, achieving eventual consistency through these mathematical constructs called conflict-free replicated data types, CRDTs, all sorts of technical stuff. But what I later discovered is historical modeling is so much more than this technical stuff. Historical modeling focuses on decisions. It's a way for you to identify the decisions that are happening within an organization and how those decisions are related to one another. So you can see it's got some things in parallel with event storming, where a lot of those domain events are decisions that people made. In historical modeling, now we're really focusing on those decisions and the relationships among them. So let me show you a few examples. So this is a historical model that I developed on a whiteboard with some stickies. So we needed to to build a system where you could purchase flights using your miles. So it's like, okay, what are the different decisions that happen within that that process? So I know that you can't quite read my terrible handwriting on those stickies. The important thing is that structure. You see all those arrows are pointing up. So there's a decision that's right in the middle that the airline has created a flight that it's going to fly from one origin airport to a destination airport. So that was a decision that somebody made at some point. And then later on, a customer is going to add that to their inventory, and then they are going to place an order. So those decisions kind of flow down the page. So I just kind of made sticky notes of all the different decisions, and I started to arrange them in order. But this time, unlike event storming, I didn't arrange them in a linear order across the page. Here I arranged it so that time flows down the page. So each one of these decisions, I call them historical facts. So it's a thing that somebody has decided to do. So similar to a domain event. And then the important thing that I wanted to capture in a historical model is which ones are related to which other ones. So we've got predecessors, the decisions that must have occurred before, and the successors, those that follow. And so you've got these arrows then that you can draw from the successor up to the predecessor. And so all of the arrows are pointing up toward their predecessors so that time flows down. And then you can see that you get this graph that branches and then it converges as people make different parallel decisions that are not related to one another. But then after a few decisions are made and then they come back together, then you can have something that brings them back down. So, for example, toward the bottom, you've got a payment of one flight based on the miles that you earned from some other flights. So that brings that history back together, and you've got that that decision that occurs later in time that wraps it all up. So you've got that idea of the partial order, the predecessors and the successors of various historical facts, which record decisions. And then another thing that that really jumped out at me when I started to draw these historical models is these regions of responsibility. So originally, I started to draw these boundaries in order to figure out, well, all of this is going to happen on this machine, and then it needs to somehow communicate with that machine in order to get things done. But then I said, wait a minute, these are areas of responsibility where the same person is making all of these decisions. And then a different person is making all of these decisions. So you put these boxes around the various business decisions, and then all the decisions within that box are made by a common decision maker. Then when you see one of these predecessor arrows leaving that box, now you know that there is a point of collaboration. This particular model, this comes from one of my collaborators. He runs a company where farm workers can get jobs and go out to different yards in order to work on different farm equipment. So so he designed this this system, and then using historical modeling, he was able to capture who is responsible for doing what. And now he can see, oh, okay, it's the distributor that's assigning the work. It's the owner that that is allocating those tasks, and then it's the worker that is taking care of what work has started and how it is completed. So he was able to draw these boxes and understand the collaborations among those different parties. And then another area where historical modeling has really helped is to call out the pain points and the opportunities. Again, you might see a parallel with event storming here. So in event storming, put that that red sticky up there to say, hey, there's something that we can do here. A practice that I really like to do is to put both the red and the green stickies up there. You know, these are things that are painful. I don't have a solution for them yet, but let me just call them out. And then the green stickies are, hey, we've got an opportunity here to take advantage of other stakeholders, engage them in the process. We've got a way that we can possibly solve this, or maybe derive more business value because of this part of the process. So this diagram here, again, it's too small for you to see the actual text in the diagram, but I wanted you to get a feel for the general shape of what we were working on here. This is one that the Improving Executive team worked on in order to better understand our own business process, and then what are some of the pain points, what are some of the opportunities that that we could engage on in order to improve those processes. It's worth noting here that in the end, we didn't build any new software. We just used this as a tool to understand the process. And that's really where I think that that everybody here can engage in some of these tools in order to get some business insights. So let me walk you through a historical modeling exercise. So similar to an event storming exercise, you're going to bring your key stakeholders together, and you're going to give them the tools, whiteboards, stickies, and ask them to build a model. Now, this time, instead of just tell me things that happened within the system, you're going to be talking about what are the key decisions that people make. So what's the decision within your domain that brings the most business value? Let's just start right there. What's the most important thing that somebody can decide to do? So in this case, we're talking about a university. And so we offer a course, and that adds value. So yeah, we haven't gotten paid for that that course yet. We have an offering, but the offering is what adds value. Okay, great. So now what comes before? What has to have happened before you can make that offering? Well, we need to have a course to offer, and we need to offer it in a semester. So that way, now we can take all of the offerings for a particular semester and we can put together a course catalog. Okay, great. That is now driving the decisions that happened before, and giving you that that view, that mechanism by which people are going to learn about these things. So you can kind of see that just taking shape with just a few historical facts. Now, okay, we understand a little bit what came before the offering. What comes after? Why did you create that offering in the first place? Well, I did that so that a student could register for the offering. Okay, great. So we've got a student is some historical fact that now we understand that this is a person that is a student of our university, and as a student, they can register for the offering. They must be a student before they can register, and we must have the offering available before they can register. So those are both predecessors. And then the stakeholders can step back and look at the model so far and say, well, wait a minute, that doesn't quite capture things. The student has to first enroll before they can register. So we want to make sure that we've got enrollment as a part of this model. Okay, so is it just that the student is enrolling? Well, not quite. They're enrolling at the university, the same university that's offering the courses and has semesters. Okay, so now we're starting to join those different parts of the model together, and we're starting to see that a student has made some decisions here, the university has made some decisions there, and the registration is what brings them together. So this is starting to talk about the entire process, not as a linear stream of domain events that have occurred across the board in time, but instead, as time flows down the page, time is allowed to branch and to come back together. So then you continue the process. Now that somebody's registered, what happens then? Well, they can drop the course, they can complete the course, or they might fail the course. So all of those things happen after registration. And eventually, one of those three things has to happen. So we say, okay, that seems like a pretty complete model of the system that we're trying to design. Now, let's go ahead and talk about who is responsible for each of these decisions. So in event storming, you put the little tags on the stickies to say, this was the person responsible. In historical modeling, what I've discovered is that you can draw region boundaries around these decisions, and they tend to clump together. So we say, okay, an administrator is making all of these decisions. They're building that course catalog. And then the student is making all of these decisions. They're enrolling, they're registering, and then it's the professor that is making this final decision of, did they complete it? Did they fail? I guess actually drop belongs in the student boundary. Should move that over there. In this collaborative workshop, somebody might point that out. Hey, that belongs over there. And so now you see the arrows crossing the boundaries, and you see those points of collaboration. And now, even if you don't build any software based on this historical model, you know that there has to be some mechanism by which a student can learn about a university in order to enroll. Oh, maybe we need a web page. Maybe we need some high school engagement programs. Whatever that happens to be, let's put that in place in order to account for that arrow crossing that boundary. The student needs to register for an offering. Oh, we need to publish a course catalog. Back in my day, that was a literal book that was sent to us, and we had to use the phone in order to register. But yeah, these days it might be online, and you click a few times, and you're registered for your offerings. And then the arrows crossing from the professor to the registration. The professor needs to learn about all the students registered, so they need a roster. Okay, what does the roster look like? How do we get that to the professor? So all these things come about from looking at this historical model and how things cross the region boundaries. So Emily, do we have any questions on historical modeling or anything else?
We do have a question. I think this came a little bit earlier, but the question is time the correct term here? Wouldn't causality be more appropriate?
Yes. Yeah, I think this might be somebody who's read my book. Yes, absolutely. Causality is really what you're measuring here, and time is a good stand-in for causality, because things that happened before, things that caused other things to happen, happened before. So yeah, the important thing here is that it's not just enough that if you look at your watch, that one thing happened before another, but really the arrow represents that one thing caused another. So yeah, causality is the more appropriate term here. Yeah, I just try not to scare people with overly yeah, overly technical terms. If we're coming into this this workshop, so very astute. Excellent. Well, yeah, to kind of wrap up, I wanted to make sure that you had access to some resources. So to learn more about domain-driven design, there's always the Blue Book by Eric Evans. But I would also highly, highly recommend the Red Book, Implementing Domain-Driven Design by Vaughn Vernon. These days, the Red Book is often somebody's introduction to domain-driven design, and it is an excellent resource. For event storming, you can go to eventstorming.com. There is an event storming book. Alberto is continually in the process of writing that book. So I don't think it's been updated in a little while, but the most up-to-date information you'll find at eventstorming.com. And then again, for historical modeling, check out The Art of Immutable Architecture. Second edition will be coming out probably the beginning of next month. So so hold off until you get that second edition. I have been Michael Perry. Please reach out to me at michael.perry@improving.com. You can also go to immutablearchitecture.com in order to find other ways to reach out to me. So Emily, do we have anything to round us out?
There was one final question, and I'm not sure what this was in reference to, but the question was, is this more of a communication issue?
Okay. So
and I'm not sure.
Yeah. So I imagine that what we are talking
time
about,
versus causality is time
okay.
versus causality more of a communication issue. Thank you for the clarification.
Yeah. Yeah. For people who are comfortable with physics, for people who are comfortable with with distributed systems and things happening in different places and causing other things to happen to take place, maybe they've already got the idea of causality being something different from time in their mind, and so I think that that it's really an idea of comfort. You have to be comfortable with the idea that two things can be causally unrelated and still happen in some order in time. It's just that you don't care what that order was. If you want to go back to one of my favorite math papers, Leslie Lamport's Time Clocks and the Order of Events in a Distributed System, he defines causality. He defines the term it happens at the same time, concurrent. He defines the term concurrent to mean that there is no causal relationship between two events. One could have happened before the other or vice versa. But now when you tell somebody that these two events were concurrent, then they might look at their watch and say, well, no, I clearly saw that one happen before that one. Like a great example is math papers. Or it always comes back to math papers. Math papers reference other math papers. So the ones that they reference happened in the past. They came before. They caused this paper to be written. But two papers that don't reference each other have no causal relationship. And yet you can still look at the byline and you can see that one was published a year before the other. But that's time. That's not causality. So I hope that helps.
Wonderful. All right, well, we're going to leave it here just 1 second. I definitely would encourage anybody who has additional questions to reach out to Michael. Michael, thank you so much for taking the time today. We really appreciate your expertise and your discussion, and I hope that people will use this either to further their understanding of I can't even talk about it, all the modeling, or get the introduction to it.
Mm-hmm.
So for everyone who joined today, this is Driving Success Through Application Modeling. Thank you so much for joining us as we go through all of this and the introduction to the class. Hopefully you'll be able to speak with Michael Perry or pick up his book. This talk is also part of a series. And so we will be back here, same day, same time, Wednesday at 12 p.m. Central, next week for Developing Modern Applications with Design Patterns, hosted by Reed Spencer. So make sure to come join us again. All of our talks can be found at improving.com under our thoughts section. So not only will you be able to see information in our upcoming talks, but if you'd like a reference or to share this presentation with somebody who may have missed it live, you can get a copy of it from our YouTube linked on that site. Again, Michael, thank you so much for taking the time, and thank you everyone for joining. I hope to see you all here again next week.